Good evening, everyone. My name is Dr. Long, and I am the proud sponsor of the STEM SAC program. And I really appreciate you coming out tonight to support your students in their senior APEX project presentations. STEM SAC, for those of you that may not be as familiar, stands for Science, Technology, Engineering, Mathematics, Student Academic Concentration. And these students have spent multiple years in a very specialized program that hones in on an area of interest, either biomedical, engineering, technology, physical science, and sustainability. And I'm just the person behind the scenes kind of directing activities and organizing the cookies and the lemonade. The people that do the real work are our advisors, and our advisors are here with us tonight. We have Mr. Matthew Peretz for technology. So everybody wave at Matthew. Mr. Scott Warner for engineering. Ms. Sarah Schlussel for biomedical. And Ms. Amy Annapolis for sustainability. Unfortunately, our physical science advisor couldn't be here because he's taking a midterm, so I told him to go and do that. We have some really wonderful students here presenting today, and if you look on your program, I've organized it alphabetically by program. Biomedical is going to be presenting first tonight, and then engineering, and then technology. All right, so I'd like to welcome first Miss Emmy Hartman.
So I decided to do my APEX project on why do I have different allergies than my identical twin sister. Next slide, please. That's my identical twin sister, Lucy. We have a lot in common. We've always liked doing similar things. We like the same foods, like the same activities. However, about a year ago, I found out that I was allergic to soy, wheat, and tree nuts and multiple other things that my identical twin sister was not allergic to. This made me question why, and I wanted to gain some more knowledge about it. Next slide, please. The first thing that I came upon when researching my topic was how physiological stressors contribute to allergies. Anxiety triggers your fight and fight stress response, which triggers or releases chemicals and hormones like adrenaline. Stressors can be something minor or major. For me, it was school. I know this might seem like a minor stress, but I put a lot of pressure on my grades and everything like that. Another one is it is thought that it happens because your stress hormones can ramp up your already exaggerated immune system. So it's not necessarily that stressors cause your allergies, it's more that it happens to ramp your already exaggerated immune system up. Next slide, please. The correlation between mutated genes and allergies. If a gene function is mutated, an allergic reaction could occur. A mutation in a gene function does not change your DNA sequence. This is important because it means that my identical twin sister and I, we have the same exact DNA sequence. However, she could have DNA methylation, which I'll talk about a bit more later, causing her genetic function to be different than mine. Next slide, please. Relationship between OCD and developing allergies. When I was 16 to 17 years old, I began to struggle with OCD tendencies. I was later put on medication. This made me wonder if there could be a correlation between developing allergies and having specific disorders. Patients with OCD and Tourette's syndrome had more severe allergic diseases than seen in other patients. This suggests that there is a correlation between OCD as well as other panic disorders. Something that I could be interested in was, could I have an allergy with no symptoms, since my identical twin sister doesn't have allergies? The answer is yes. My gastroenterologist actually explained to me that even though these allergies are present, it doesn't mean I will have symptoms when eating these foods. When we come in contact with something we are allergic to, our body makes antibodies against it. The antibody tells your body to release chemicals and include histamine, which is the main hormone release that causes allergic reactions. Next slide. How your diet affects your chances of developing allergies. When I was in 4th grade, I decided to become a vegetarian because I felt bad for the animals. And my parents were like, okay, well, you have to eat or get protein within your diet, even though you're not eating any animals. So the deal was that I would eat fake protein-based meats, which I was unaware, but they contained soy and wheat. Over time, your body will tell you to release histamine, causing an allergic reaction. Again, this happens slowly over time, but since 4th grade, I've been a vegetarian, so that could have definitely helped contribute to that. Next slide. How epigenetics and DNA methylation contribute to allergies. Scientists have found that people have less allergic rhinitis when on break from work or school. This is due to them spending more time at home and less time outside. This study helps bring attention to epigenetics as well as the alteration of DNA methylation. It is important to state that epigenetics is how your allergies are affected by your environment, that you're outside and inside. DNA methylation is a biological process where methyl groups, hence the name methylation, are added to the DNA molecule. This can change the activity of the DNA segment without changing the sequence. I will go a bit more into depth about DNA methylation since it's important within my topic. Next slide, please. This is my first part of my data analysis. This shows that it's the subject demographics for twins discordant for asthma, meaning this is for 2 monozygotic twins, which are identical twins, who one has the allergy or asthma while the other one doesn't. So this went along with my study since I have allergies and my sister doesn't. This just shows that patients went from more severe or mild to severe moderate symptoms with asthma, and then the non-asthmatic who had mild, or if any at all. Next slide. This just shows that in a better picture, a bar graph, and it's the same thing, just explaining that the asthmatic patients, they had more symptoms than the non-asthmatic patients. This is my next data analysis. So on this side, it's quite small, you can't read it, but it says Tregs. Tregs regulate T cell function and inhibit your autoimmunity. So if you look at the non-asthmatic versus the asthmatic patients, you see that the non-asthmatic, their level of Tregs is much higher. This shows us that it is inhibiting the function of autoimmunity. So non-asthmatic patients aren't as prone to having autoimmunity, which is an allergic disease, autoimmunity as well. Next, please. This is my last data analysis. This shows the difference in methylation, which I said I would get back to. The blue one is the non-allergic patients or twin, and the brown one is the peanut allergy. In this you can see that the blue one, the non-allergic patients, is higher within the SERPINE1 gene, and this shows that there is more DNA methylation present in patients who do not have allergies. This means that my sister could have, I call it like a cap, it's like a DNA cap methylation that's on the DNA. It could mean that she has the cap on telling her genetic makeup or genes to make this function of not being allergic to this. Well, I don't have them. And that could be another reason. Next slide, please. This is my conclusion. Although there isn't necessarily one specific answer to my question, I found many possible reasons for the differences in my health and my identical twin sisters. Allergic reactions can happen for different reasons, one of them being stress. Although stress can't cause allergies, it can cause your allergies to flare up. Other correlations were found, including your diet and developing allergies later in life, the heritability of allergies, epigenetics, and your mental health. Thank you.
Thank you, Emmy. You did a great job. I'd now like to welcome Mr. James Tanis in his presentation on transplantations and ex vivo perfusions.
Hi, my name is James Tanis, and I have done my presentation on transplantations of hearts and ex vivo perfusion. So The first thing I want to talk about is what an organ transplant really is. So an organ transplant is when a donor has a healthy organ and it is donated into the body of another living human being. They're done to save lives with people who have organ failure or other life-threatening illnesses. Next slide. Yeah. So another thing that needs to be addressed is what the timeline of a heart transplant really is. So even though the main focus here will be the heart, the other organs that are normally transplanted, such as lungs, livers, and kidneys, have similar timelines to them. So the first step is finding indications that a transplant might be needed. The first thing that needs to occur is a patient must have symptoms of abnormal behavior within the heart. If a heart transplant is needed, they would usually have advanced heart failure symptoms or other, like something like heart disease. And the next step the patient would go through is a few cardiopulmonary exercises, and then would be tested if a heart transplant is needed. Anytime you see an HT in the presentation, it stands for heart transplant. So step 2 would be to evaluate the heart transplant candidate. Since healthy hearts are in high demand, it is very important that a patient is in last resort before they get a heart transplant. Because of this, the patient must go through a series of other tests before they are ready for the transplant. The patient must have all other non-cardiac organs evaluated to ensure that they will not affect the post-transplant outcome. This is like liver, lungs, all this other organs in the body that would affect the heart. Once the patient is cleared, they are put into a waiting list with other candidates in their similar condition. So after they're put in this list, the patient has a matching process they must go through. This is where the donor heart is evaluated to see if it fits a recipient. In the matching process, things like gender, weight, size of the person, age, and blood type are taken into consideration. And once a patient is matched, the heart is removed and transplanted into the recipient. So that's kind of a basic outline of what a person that needs a heart transplant goes through. And the biggest question I had was, what if there needs to be a transportation from one hospital to another or around the world? And so that's what I mainly did my project on. And up there is what I'll go into that, what that is. So after the donor heart is removed, it is usually moved from one part of a hospital to another, but what happens if the donor and recipient are long distance away? Traditionally, the donor heart is put on ice and is put into the place it needs, but there are new ways to transplant organs, and that's what this is. And that basically is that smaller version. So what this is it's like an artificial heart, artificial human body. A human heart from a donor is put into this machine, and it is kept alive for more than 24 hours. And like I said, traditionally it's put in ice, and that would last for 6 hours. And now something like this can last up to 24 hours or longer if needed. So next slide. Through ex vivo perfusion, the heart can last up to 24 hours compared to 6 on ice. The heart is put in an artificial body that keeps it warm, circulates nutrients, and pumps blood through the heart. Doing this allows for the heart to be moved anywhere around the world and not have to worry about damage to the heart. So the next slide. So this is kind of a basic outline of what that machine is doing. Blood is being pumped into the aorta, and it fills the coronary arteries that then goes back through oxygenated blood and through the heart and basically keeps it alive as if it was in a human body. The only difference between this and a human body is it's being pumped through the aorta and not the pulmonary artery. This fills the coronary arteries and keeps the heart alive for a period of time as if it was in a body, then can be moved to anywhere it needs to go. I have a video. So this video is basically that. Oh, it's sideways. That's okay. You see the heart pumping. So if you can see the heart beating, that's a sheep's heart. And basically, as that represents a human heart, and that's what that's going to do. So after everybody's done presenting, you can come up here and see this thing live. But yeah, and can you pause it here? I wish it was, yeah, not sideways, but yeah, big frame. Yeah, all right, so it goes to the reservoir, goes through, pumps through the oxygenator, through the aorta, out the pulmonary artery, and is drained through the left ventricle and back into the reservoir to be continuing pumped. Now, if it was the real thing, it'd be blood, and it'd be oxygenated, neutralized, and everything to keep the heart alive for the period of time it needs. That's my presentation. Thank you.
All right, so we're now moving on to the engineering division, and I'll keep from gushing because the next one is related to me. This is Forrest Long, and would tracking solar panels be more effective to collect power than solar panels that stay flat on the roof of a home? Please welcome Forrest.
Good evening, everyone. My name is Forrest Long, and I'll be sharing with you my APEX project, which is going to be focused on voltage production between stationary and tracking solar panels. Next slide. Oh. Okay. By using my solar science station kit, I was able to take down the voltage every 5 degrees every hour. I was able to determine whether solar tracking is worth the money, the time, and the maintenance that it would take to be produced and created on your own home in real life. Next slide. The purpose of this experiment is to show the difference in how tracking solar panels versus ordinary solar panels would do in your home, and to determine whether the cost versus the energy return would be worth your money and time. Next slide. In order for tracking solar panels to be more effective, they would have to show significant difference between stationary solar panels and the maintenance and materials worth the cost. Next slide. During the course of this experiment, I learned that there are a variety of variables that can interfere with the experimental results. For example, cloud interference, along with radiant energy being allowed through the atmosphere. Another issue that I was encountered was the solar panel needed around 4.5 volts just to even display anything on the actual front of the solar panel, which I have here in my hand. Next slide. I found in my research that there's an extraordinary difference between installing solar panels that go on your roof and solar panels that track the sun while also being on the roof, and the reliability of this type of solar panel is significantly decreases because it can easily break down. Next slide. My hypothesis during this experiment was that I believed that when tracking the sun, the solar panel would show as much more of a significant difference than it would not, than as if it was not tracking. Next slide. So in order to collect all this data, I collected a quantitative measurements included right here in this chart for 12 hours, for a 12-hour period for 3 days, 5 data points, and were collected at 5 degrees from 0 to 180 degrees each hour. Next slide. All my data was entered into the graphs by hand. Axis 1 represents the sun if the sun was pointing directly at the angle of where the sun was during that time of day. Axis 2 shows the data where the solar panel was lifted up and given the best chance for the best amount of voltage production. And axis 3 is when the solar panel is exactly at 90 degrees to show how much energy we would get if we just pointed the solar panel straight up at a perfect 90-degree angle. Next slide. Once all the averages were collected, I compiled them into this graph to get a percent average voltage for each day and the difference of the voltage produced between the axis. This shows that the graph before I applied those averages and after. Next slide. These pictures will show you how I was working with the data points during the collection phase. This was the exact position that I placed the solar panel each and every time that I went out there for those 3 days and recorded the data in order for the data to remain constant. Next slide. As long as the meter had enough voltage to appear on the display, I recorded 5 data points for each of the degrees of movement from 0 to 180 degrees. The data recording started at 6 a.m. and ended 12 hours later for 3 days total worth of data. Next slide. The minimum materials that I took were just the solar station kit created by the Brown Dog Lag Company and a laptop. Next slide. So this very hand-drawn sketch was how is just kind of like a poor representation of how I did it. So this slide shows the different axes and angles and how I recorded the data points were and how they were collected. This just shows the visual outlook on each angle that was recorded and the position of the solar panels. Next slide. So this link will take you to the Sheets document, which could we go to now? If we could click on that. There are 3 separate days with the same data points, and I have all the Sheets documents. I guess they just don't want to load up on here, so we'll go ahead and skip that for now. So next slide. So these are about the averages that was collected from each and every day. Analyzing the complete data collection for day 1, there shows that there is little difference in the voltage output between the axes. Next slide. With day 2, it shows the average was a bit closer than before, but I'm assuming that was because of the clouds and how they were more active, more out that day. And then, but it's still similar to the one before. And then next slide. And then during the last day of the data collection, the 2 axis point stayed on top of all the lines. Next slide. I conclude that the different axes between tracking versus non-tracking solar panels were not as significant as I believed that they would be to start. Next slide. And that the data does not support my hypothesis because the amount of energy that's produced moving solar panels does not produce enough energy to support the extra expense of changing it from a static collector to a movable one for just a 20% average increase, and that truly wasn't worth the mechanics and the upkeep for the extra voltage. It would just be more economical to buy a stationary solar panel instead of one that was able to move. Next slide. I wanted to thank Mr. Warner for helping me guide me through this experiment, along with a special thanks to my mother, Dr. Long, for helping me be a mentor and a guide for collecting the data during this experiments. And I also like to thank Coach Griffiths for helping me with the building of the solar panel. Thank you.
Next, we'll have Xavier Williams for the magnetic battery train. Xavier?
Hello, my name is Xavier Williams, and today I'll be presenting my project on electromagnetic battery trains. This project is designed to answer the question of how the number of magnets used affect the time at which a battery can travel through a bare copper wire coil. I predicted that more magnets would decrease the time it takes, but only up to an extent. This report explored some findings, such as diminishing marginal magnetic force from the stacking of magnets and how electromagnetic fields can interact to transport objects. Furthermore, this ties in with analyzing the fundamentals of revolutionary transportation, like the bullet train, which operates on a magnetic levitation and electrodynamic suspension systems. Next slide, please. For the materials, I used a AAA battery, a 2x15mm neodymium magnets, non-insulated copper wire, a recording device or stopwatch, and a Tesla meter. For the methodology, I used rotary machinery or a round object to wrap the wire in a coil. The coil must be wrapped tight and uniformly to prevent the magnetic fields from being out of uniform as well. This will make sure the battery train will travel normally. Neodymium magnets must be larger in diameter than chosen battery, but smaller than the coiled wire diameter. This is so the magnets can make physical contact with the wire, rather than the battery, which in turn will create the closed circuit essential for the experiment. The battery must not be dead, because the circuit will not work without a voltage source. Magnets are to be placed near the battery with the same attraction and opposite direction. This is further highlighted and explained in depth in the conclusion. Next slide, please. For my sub-experiment, I used a Tesla meter to record the magnetic field strength between magnets. add additional magnets in a container of slightly larger diameter while recording that magnetic field each time until the difference in magnetic field strength is insignificant and thus unrecordable. Next slide, please. This data takes the time to travel a meter and the speed for each additional magnet. Next slide, please. This graph's piercing coefficient is recorded to be negative 0.8436. This shows a strong inverse relationship between the number of magnets and the time it takes the battery to travel 1 meter. Nonetheless, the data in the graph begins to plateau after about 5 magnets are added. This helps illustrate the decreasing marginal magnetic field that comes with stacking magnets. Next slide, please. This graph's piercing coefficient is recorded to be 0.892167. This graph is essentially an inverse of the aforementioned data and was recorded for the purpose of showing the strong correlation between the number of magnets and speed. Next slide, please. This is the data for the sub-experiment. The sub-experiment was designed to show the decreasing marginal magnetic field with each additional magnet. Next slide, please. The graph suggests that adding magnets will increase the magnetic field, but at a decreasing rate until it eventually plateaus or is considered insignificant. The piercing coefficient of this graph was recorded to be 0.835417. This shows that there is a strong relationship between the number of magnets and the magnetic field strength. With all the numbers out of the way, it's time to get into the meat and potatoes. The battery chain functions from the magnets on both sides of the battery contacting the copper wire. This contact with the copper wire produces a closed circuit which allows for the flow of current as the battery provides an arbitrary voltage that is stored on it. This is modeled in the equation V is equal to IR, V standing for potential difference, I standing for current, and R standing for resistance. In an ideal scenario, a battery will not have internal resistance. However, when experimentally tested, virtually every single common use battery will have some internal resistance that can affect the strength of the current that will flow through the copper wire. Resistance is inversely proportional to that of current. If the resistance is to increase at a significant value, then current will decrease. This will in turn decrease the magnetic field that is created around the copper wire, as magnetic field is proportional to current due to the battery train being a solenoid. This means Ampere's law applies, and B equals U naught NL. N being the number of loops of wire per unit length, U naught being permeability, and I being current. Next slide, please. The battery progresses throughout the coil due to the continuous flow of the current to the closed circuit, leading to the interaction between the copper wire magnetic field and neodymium magnetic field until either the battery is drained or there's no copper wire left. Next slide, please. Battery trains finds its basis in electromagnetism. As aforementioned, the contact between the magnet and the copper wire produces a closed circuit, which is best represented in figure 2 here. The resulting magnetic field, which is shown by B in figure 2, circulates in relation to the direction of the current, which is determined by using the right-hand rule as modeled in figure 3. For those unfamiliar with the right-hand rule, the right hand says the direction of your right thumb follows the current, and the direction of the magnetic field follows the curl of your fingers. Next slide, please. With the fundamentals out of the way, let's get into the physics about why the battery moves throughout the coil. Next slide, please. Each neodymium magnet has a north and a south pole. These poles are of opposite charges, with the north being negative and south being positive in general situations. Now for the important part. The magnet's north poles must be pointing away from each on each other's side. The front magnet must be getting pushed away while the back magnet is getting pulled. This is best illustrated in figure 4 with the virtual bar magnet showing. One thing you probably notice is the virtual bar magnet. This magnet does not physically exist and is a result of the closed circuit that is formed. To reiterate, this circuit means that a current is produced which creates a magnetic field from the copper wire. This magnetic field is why the front magnet is being pushed away while the bottom magnet is being pulled. Don't let the attraction to the battery itself fool you when designing this experiment. It will not work if you don't design it as shown in figure 4. So make sure they're positioned in a way in which they are repelling each other. before placing them on the battery. Next slide, please. Before I recorded my sub-experiment, and I wasn't certain of the diminishing marginal magnetic field being the cause due to how spontaneously my first 2 graphs plateaued, I concluded that using more magnets would produce a stronger magnetic field, which will result in the battery train traveling faster as analyzed. However, the reason why the time stops making significant changes after 5 magnets on both sides is because the magnetic force will only increase until the length is about equal to or greater than the diameter of the magnet itself. This is proven to be partially false, but I find it evident that increasing the number of magnets led to a higher mass, which led to a higher inertia, and finally resulting in a large resistance to change in motion. Next slide, please. To help scientifically prove the reason why the battery stops traveling, I created a sub-experiment in this lab. This sub-experiment ratified that each additional magnet comes with diminishing marginal field strength. This means the magnetic field will increase at a decreasing rate. However, the rate won't be negative, and the field strength will be at its maximum and constant when the rate is 0. Human error in the data collection led to magnetic field strength falling below its max. After roughly 9 magnets, the rate at which the field strength increases for each additional magnet is low and eventually near 0. This means that in the main experiment, I was essentially just increasing the mass on the battery. Nonetheless, it becomes difficult to work with many magnets in a train. The magnets on the far end provide very little magnetic force on the battery itself due to its distance and become prone to colliding with the sides of the coil, which makes the train non-uniform. Next slide, please. Thank you for listening to my presentation.
All right, we now move on to technology and Mr. Ethan Kaufman, experimental framing's impact on human connection with chatbot programs. Ethan?
Hello, my name is Ethan Kaufman. My Apex project was on experimental framing's impact on human connection with chatbot programs. Next slide, please. Start off, what is a chatbot? A chatbot is basically a computer program that mimics human connection. However, chatbots possess no actual intelligence, they are not human, and they would not even be considered artificial intelligence. Despite this, chatbots can accurately fool humans into thinking that they are a real person. Chatbots operate by looking for keywords and messages and then replying with a pre-programmed response. Depending on how much time the programmer is willing to sink in, chatbots can simulate a multitude of responses and appear to have relatively complex conversations. However, chatbots are not the only non-human thing humans have been known to connect with. Next slide, please. Humans easily connect with inanimate objects and animals that possess no actual human emotions. This robot appears friendly and welcoming despite not possessing any of these qualities. Next slide, please. Associating a non-human entity with human characteristics is known as anthropomorphism. Next slide, please. What I wanted to know is compare external circumstances such as appearance and how it would affect how humans connect with it. Basically, is the human connection with chatbots a result of external circumstances like appearances such as smiling or being called by a name, or is it a result of the behavior of the chatbot itself? Next slide, please. I wanted to see if simply changing the way a chatbot program was perceived without changing its actual programming would impact how much humans report to connect with the program. Next slide, please. For my experiment, I utilized the Alice chatbot. For the control group, Alice was presented as an it, and the website did not have a photo with her name present. For the experimental group, Alice was referred to as a human female and called Alice. A photo was also present on the website of a simple human face. Individuals were instructed to have a conversation with Alice. Initially, I aimed to have humans ask questions to Alice, but this quickly became confusing as people were unsure what the actual purpose of the experiment is. As such, I found much more success when just instructing people to simply try and talk with Alice like you would a human. Afterwards, each group took a survey where they rated their connection to Alice. The surveys were slightly modified based on which groups took the surveys to be consistent with how Alice was referred to in the experiment. Next slide, please. And here you can see the survey. The survey had 6 questions, the questions being, are you afraid of Alice? How valuable do you think Alice is? How connected do you feel to Alice? Do you trust Alice? Do you consider her your friend? And if you were to discover that Alice were to be deleted, how upset would you be? The responses to these surveys were recorded on a scale of 1 to 10, and the ones you see here on the slide were for the experimental group. For the control group, basically just replace Alice with it or the program. Next slide, please. And here are my results. In the categories of connection, trust, lack of fear, and friendship, there was a greater level of sympathy shown by the experimental group when compared to the control group. Next slide, please. So, what does this mean? There is definitely a correlation between presence of factors like a picture of a human face and being referred to by a human name and emotional connection reported. This suggests that the appearance and presentation of chatbots plays an important role in how we as humans relate to them. What this means is that computer programs can be made personable simply by adding additional external factors without even changing the programming and the computer language at all. Additional research is needed due to the limited scope of my project. My control group was about 30 people. The total number of participants was about 30 people. The control group was 19. The experimental group was 11. That kind of uneven distribution is due to random assignment. And ideally, I would conduct the experiment in person, but I had to do it in kind of a more virtual fashion. Next slide, please. My personal observations on this experiment is that I noticed most individuals rated their connection with Alice on a fairly low level, usually below 5. This was to be expected as Alice can become confused and repeat herself very easily. Some even remarked that this bot is really stupid. However, a few individuals from both the control and experimental groups genuinely seemed to connect with Alice and held long conversations with her and expressed additional interest in chatbot programs with me afterwards. I also noticed that teenagers seemed to have a much better time understanding and connecting to Alice than adults. It's fascinating to me the level of connection that some individuals have recorded with Alice. As I did some research, I found that this sort of thing is fairly common with chatbot programs, with usually 1 or 2 people. And there's actually several people who are convinced that the Alice program itself is actually sentient, despite the fact that Alice's creator has gone on record of claiming it is not. And I, for one, support that. While I guess the poetry of the so-called rogue AI is interesting, Alice is really nothing more than just pre-programmed responses to things you type in. Next slide, please. This is a sample conversation with Alice. It gets quite a bit repetitive. Alice seems to get confused and repeat herself. Next slide, please. Thank you for your time, and I appreciate you listening.
Next, I want to welcome Krishna Patel and Salome Ramirez on their project on simulations.
Okay, good evening, and thank you for joining us to watch our APEX presentations today. Salome and I conducted our APEX project on simulations, and so as technology has been progressing in our world, simulations are becoming more and more common. And basically, these simulations can be used to test new technology, test new projects, whether it's in the engineering field or the medicine field. And so we just wanted to kind of test out how accurate simulations are. And so we kind of conducted a test between data from the simulation and data in real life.
The simulation we chose was called The Islands. This kind of simulation is a virtual human population, and every island has different households in it. Within each household, there's villagers living in it. You can ask the villagers to perform different kinds of tasks, and they will give you data back. Our question, next slide, sorry. Our question was, how accurate are simulations when it comes to balancing on one foot with your eyes open and closed? In order to test this, we collected data from the real world by asking some volunteers to perform those same tasks, and we collected the data from the simulations by adding other from the villagers. Our hypothesis stated that because of external factors such as athleticism, different procedures taken to measure the experiment, and settings, there will be a negative correlation between real-life data and simulated data. Next slide, please. Our procedure consisted from gathering the data from the simulation. So we basically used a random selection to pick the number of villagers that we were going to use and the different houses that we were going to use. We asked the villagers to perform the task, and we collected the data in seconds about how long they could stand on one foot with their eyes open and closed. For the second step, we collected the data from volunteers at the school, and we asked them to perform the same tasks, balancing on one leg with their eyes open and closed. And then we made graphs and analyzed our data. Our materials involved an iPad for a timer, volunteers at the school, and a graphing calculator in order to graph our data points. As you can see, this picture is one of the villagers, and we asked her to perform the specific task, and she's going to give us the data back. Next slide, please.
All right, so this is kind of all the data that we collected. On the right-hand side is the data that we collected from the simulation, and then on the left-hand side is the data that we collected from students at the school. And so basically, for both, we asked them to balance on their leg, on one leg with their eyes open versus closed, and then we tried to hold all variables constant. So we kind of tried to have the same amount of males and females and things like that. And so this is kind of all of our data. Next slide, please. So from our data, we created a graph. The blue line that you can see on the graph is the data from the simulation, and the red line is the data that we collected from students at the school. And then we also pulled out the mean from the simulation and the real-life data collected. So what we noticed was that for the time balanced with your eyes open, the difference was very, very large. For the people in the simulation, it was 35 seconds, versus people at school were able to balance for 217 seconds. And that's along the x-axis, which is why there's such a big difference between the blue and red lines. But what we also noticed that for the eyes closed, the time balance was very similar. For the simulation, it was 26 seconds, and for real life, it was 27 seconds. So this is very similar, and that's why the y-axis, the data points aren't so spread out. Next slide, please. So what we concluded was that for the eyes open, the data with the simulation was very different, and then for the eyes closed, the data was very similar. And so, like we said in our hypothesis, simulations cannot predict external factors like human intuition. For example, when we balance with our eyes open, we can stare at a certain, like a point across the room or things like that to help us out, which the simulations won't factor into. They also won't take into account like atmosphere or athletic ability and things like that. And so, overall, simulations are improving, but they still need work. Next slide, please. To reiterate, our study used a very small simulation that was open to the public. Our goal was to determine if such small simulations that are free and available to the general public are accurate enough to use in smaller projects around different studies. And so overall, they are improving, but they still can't predict external factors, and so that's something that needs to be worked on before we use simulations on a wide scale. Next slide, please.
Some errors that we encountered while doing the experiment was that we did not consider age into our experiment and our calculations. So while the data from the simulation had mostly villagers from their mid-30s, our MVA students were mostly 17 and 18 years old. Another error that we occurred was that MVA volunteers used different legs instead of keeping one leg consistent, so only right leg or only left leg. So we didn't keep that consistent in our things. And then there's other variables that can produce faulty results and that we cannot determine is this cause and effect.
So for next time, if we were to redo the study or if we had more resources, firstly, we would like to create a specific definition to test the volunteers so we know that we're holding everything constant possible so that we don't have outside variables affecting our data. We would also try to look for residents that are of similar age and things like that so that we could compare the simulation to the real life more accurately. And finally, we would like to try different simulations, smaller ones like this one, as well as bigger, more expensive ones, just to see how accurate simulations really are right now. Yeah. Next slide, please. Thank you for listening. Yeah, that was our presentation.
For our final presentation, we have Marco Garcia and Mateo Ortiz, the development of auditory stimuli on the development of circadian rhythms in juveniles.
Thank you, Dr. Long. Good evening, everybody. I know y'all want to see James make that sheep heart pump, but you got one more presentation to sit through. All right, I'm Marco Garcia. This is Mateo Ortiz. And with a special thank you to Dr. Felipe Ortiz for helping us design this experiment, we're here to present to you the effect of auditory stimuli on the development of circadian rhythms in juveniles. All right, so just to start off, what is a circadian rhythm? What am I talking about? Well, a circadian rhythm is defined as a cycle of physical, mental, or behavioral patterns or changes based on a 24-hour cycle, hence the name circadian, which means 24-hour. Almost all organisms, from humans to microbial creatures, go through some form of circadian rhythm, the most notable one being in regards to sleep. Next slide, please. So, how do circadian rhythms form? Well, it has a lot to do with the brain. It's controlled by a cluster of neurons found within the hypothalamus. What is the hypothalamus now? Well, it does a variety of tasks, including management of hormone release and, well, the development of circadian rhythms. Excuse me. Circadian rhythms are formed in response to the eyes picking up the rising sun, or at least that's how it evolved. Humans are naturally programmed to wake up in response to light, even when your eyes are closed. And the body records this cycle within parts of the brain, specifically the hypothalamus. And these cycles, these recorded cycles, are based on a 24-hour period, as previously stated. However, they're specifically linked to the day-night cycle of whatever region you're living in, and that is developed within the lifetime of the individual itself. Next slide, please. So the natural question is, wait, I don't wake up to the sun's light. I wish I woke up before the sun came up. Instead, we wake up to what? An alarm clock. We wake up in response to sound. Now, that is not how the brain is meant to function. However, many individuals, including myself, have reported instances in which they wake up in anticipation of their alarm clock going off. Does this mean a circadian rhythm is developing? Despite the fact that light reception is not occurring, that is the question of our meta-analysis.
So our experiment, the materials included in our experiment are 10 human subjects of similar state of mind in order to eliminate unnecessary factors such as stress and anxiety, and they are all juveniles between the ages of 12 and 18 because this was conducted at a high school. The other thing is that all subjects have a comfortable space in order to routinely sleep without any lack of loud noises or possible disturbances in order for more effective data collection, and an alarm clock to wake the subjects up all the time, every time. Next slide. So our procedure included gathering the necessary materials, and to note, subjects were responsible for collecting their own data and reporting them to us. The subjects are to go to bed at 9 p.m., and when they wake up was varied, depending from subject to subject. But they were instructed to set their alarm clock 1 hour prior to their normal wake-up time. And then subjects are to routinely wake up slightly before the alarm sounds, naturally, 5 minutes or less before their alarm clock sounds in order to consider it for our final conclusion. We waited until they consistently woke up 5 minutes prior or less prior to their alarm clock, and then we asked them to do it consistently within a series of 5 days, and if they woke up consistently prior to the alarm clock for the majority of those 5 days, we then considered it for our final conclusion.
All right. Right here, you can see our beautiful raw data. Originally, I planned on going through each and every one of the subjects. Not going to bore you guys with that. So to move on to our data analysis, you can see here that we had a more or less normal distribution with a mean time of about 4 to 5 days to develop a new circadian rhythm. It should also be noted that every participant in the experiment did develop a circadian rhythm based on their new alarm clock schedule, which definitively answers the question, at least in the terms of this experiment, that yes, you can develop circadian rhythms in response to auditory stimuli such as alarm clocks. And what's further, we have done studies here on how long it takes. So the answer, 4 to 5 days.
Conclusion, you wake up to sound. Congratulations! When the subjects woke up consistently 7 days in a row prior to their alarm clock sounding, it proved you do wake up to sound from your annoying alarm clock.
Which I'm sure everybody in this room already knows, but we proved it with science. So, what can we learn from this experiment? And I don't just mean what we can take away, but what can we do further? Because there were several possible sources of biases in our experiment. That's not really, I'm going to dodge the blame here and say it's not really our fault because of the limits of our experiment. As stated previously, our sample size was limited to a high school. We can only apply these conclusions to people aged 12 to 18 because we had no data points of younger or older ages. What's more, several factors could lead to some bias. For example, we had the participants in the experiments take the data by themselves, which that's not consistent amongst all groups. We told them to be as consistent as possible, and we trust in our subjects, but we'd rather have them in a definitively consistent environment. It's been suggested a hotel could satisfy this. So in a future experiment, we could pursue a setup within a hotel in which all individuals have the same alarm clock, the same bed, the same wake-up time, and the same time of going to bed. What's more, we could use CAT scan technology in collaboration with this to specifically measure how the different parts of the brain communicate with each other. To briefly summarize how an alarm clock works, the loud noise triggers our amygdala, which handles our sudden fear response, among other things, which shocks us awake. This has to be communicating with the hypothalamus in order to record the circadian rhythms. The only way to find this out definitively is with, as previously stated, some form of brain scan or CAT scan, which is very obviously beyond our capabilities. Which I say, but there is a pumping sheep's heart right there, so I don't know what to believe anymore. All right, that is the end of our presentation. Thank you all so much for listening and coming out tonight.